Sum and product of roots. Actually touched on this idea at the start of the topic. Basically what we're saying is the two solutions or the two roots or the two zeros, depending on what you want to call them, but we're going to call them alpha and beta. So they're the solutions to this particular equation. So if that is true, it must be possible to factorize that quadratic to be x minus alpha, that would be one solution, x minus beta, that would be another solution, but a out the front, of course, because it's not monic. Now if I expand the right-hand side out, and then divide by a, and now what I can do is I can equate all the coefficients. So, well, x squared now is 1 on both, so that's fine. But it therefore must be true that alpha plus beta is minus b on a. And that's what we call the sum of the roots. And then alpha beta is c on a, product of the roots. When I say we touched on it earlier, remember those questions where I said, find the quadratics whose roots are, and all I did was I looked at it and said, oh, well, they multiply together to give this, so that'll be the last number. They add together to give this, so that'll be the middle number. Basically, it's this idea I was using. So 2 and minus 3, instead of going x minus 2, x plus 3, expanding the whole thing out, what I can do is say, oh, well, the sum of the roots is minus 1. The product of the roots is minus 6. So therefore, the equation must be x squared plus x minus 6. When it comes to the sum of the roots, it's minus b on a. So we have to change the sign with that one. I didn't have to worry about monic in this case because it's an equation rather than a function. So if I had multiplied the whole thing by a, then I could just divide by both sides by a, and 0 divided by a is 0. So in this case, I just make them all monic. I just think it's easier. Here's one where we're talking about surds for the roots, but that lovely thing happens with the surds because the sum of the roots, the surds cancel out. I've got 2 plus 2 is 4. Product of the roots, I get difference of 2 squares. So again, the surds disappear and I end up with minus 1. And so the equation is x squared minus 4x minus 1 equals 0. All right. But we can have more fun than that. Alpha and beta are the solutions or the roots to this particular equation. Find. And what you'll usually find is the first question is usually alpha plus beta. And all we've got to do is look at our equation and go, alpha plus beta, that's minus b on a. So sub that in and we get 3 on 2. Alpha beta, that's c on a. So in this case, minus a half. But then they ask questions like this. What's alpha squared plus beta squared? Now it's very tempting to say, oh, well, I've worked out what alpha plus beta is, so I'll just square that. But that doesn't work. Alpha plus beta squared is actually alpha plus beta all squared minus 2 alpha beta. And that's just a rearrangement of the expansion of the alpha plus beta all squared. I've moved the 2 alpha beta term across. That question, I love to ask that question, the sum of the roots squared. So remember that idea, alpha plus beta all squared minus 2 alpha beta, and the question becomes quite easy now, because I can substitute in what we've already found for alpha plus beta and alpha beta, and I've ended up with 13 on 4. Another type of question they love to ask, oh, what about if it was the reciprocal of the roots? Well, I just treat this like an algebraic fraction. And so, okay, I'll put everything together. The common denominator would be alpha beta. So on the top, I'd get beta plus alpha. Although I've written it as alpha plus beta, it's the same thing. But again, we know those two things. So I can substitute in, and we get minus 3. Find the value of m if one root is double the other. Okay. So for this one, instead of saying the roots are alpha and beta, one root is the double of the other. So I'm going to say the roots are alpha and 2 alpha. One is double the other. So the sum of the roots, instead of being alpha plus beta, now becomes alpha plus 2 alpha. And I know that's going to be minus b on a, so that turns out to be minus 6. And the product of the roots will become alpha times 2 alpha, and that's going to equal C on A, which in this case is M. Well, using the first equation, I can find that alpha is minus 2. Then I can substitute it into the second one and work out the M, which is what they want me to find. M times 2 alpha squared. Eventually, there we go, M is 8. M is 8. A little bit more involved this one. This time we're going to find the value of M. Our equation is 2m minus 1 x squared plus 1 plus m x plus 1 is 0. One root is the reciprocal of the other. So instead of being alpha and beta, I'm going to call them alpha and 1 on alpha. Now the nice thing where one root is the reciprocal of the other is something really clever happens when I look at product of the roots. If you multiply a number by its reciprocal, what will you always get? Yeah. So I don't actually have to know what the root is. I can say, well, product of the roots, C on A, will be 1 on 2m minus 1. So I know that's going to be 1. And I can just solve that to work out M. And there it is. M is 1. So when you see reciprocal, have a look at product of the roots. A lot of times something nice will fall out. Okay. 8H.